Okay, we're doing exercise 11D from the first year mechanics textbook, and on question 1 we've got 3 expressions for velocities, and we're asked to find expression for the displacement. So that's going to involve integrating velocity to find displacement, and they've told us for each of those when t is 0, s is 0. So that will be relevant, they won't tell you that for no reason. Okay, so the question A, v is 3t squared minus 1. So s will be the integral of that. So s is going to be, so I'm going to increase the power to 3 and then divide by 3, so we'll cancel with the coefficient that's already there. And I must put plus c, so even if you've already looked ahead and you've realised that for the fact that, so they've told us that t is 0 and s is 0, so if you substitute those in, you are going to get c is 0, but you must still have the plus c there. Okay, so even though it's going to work out to be 0, if you just don't acknowledge it, you will lose marks for that. So for b, the function is 2t cubed minus 3t squared over 2, so we're going to integrate that. So that's going to be 2t to the power of 4 over 4 minus, so for this one, so when I increase that to a power of 3, that's then going to cancel with the 3 that's already there. And again, don't forget the plus c. But again, if t is 0 and s is 0, that would mean that c was 0. So s, so that can simplify down to t to the power of 4 over 2 minus t cubed over 2. Okay, and then c, so for c, I'm going to rewrite that square root as a power of a half, because that's the form I want it to integrate. So I'm going to integrate that, so that power is going to increase to 3 over 2 if I add 1 to it. When I'm dividing by 3 over 2, that's the same as multiplying by 2 over 3. So if I multiply that by the 2 that's already there, I get 4/3 as my coefficient. And I'm going to increase that power to 3, divide by 3. And again, I must put the plus c, even though when I substitute those values in, I do get that c is 0. So displacement is 4/3 t to the 3 over 2 plus 4t cubed over 3. Oops, sorry, that was in the way there. Okay, so let's just go back to the solutions, right, so you can actually see them. Okay, so let's just double check those against the textbook answers. Yeah, I think we're good.